Okay, so matrices lesson 1. This is going to be adding, subtracting, scalar multiplying matrices, and also using matrices to represent real-world problems. Okay, so the first thing that we need to go through is some terms that we are definitely going to need to know for this lesson and several other lessons. Okay, so first off, what is a matrix? Well, a matrix is an organized set of numbers. It's a way of organizing the numbers, basically. Not like the movie, although if you've ever seen it, and that one scene where he's looking at the computer screen and all those numbers are kind of flashing by, that really is a matrix. It's an ordered set of numbers. Okay, it's just we're not going to be dealing with anything as quite as big as what they were looking at on that movie. Okay, so an ordered set of numbers. Now, the way we describe a matrix is through its dimensions, and we're going to talk about elements in a minute. But the dimensions basically tell us the length and the width of the matrix. Now, imagine if you were going into like Lowe's, right, to buy some lumber because you're going to help build a deck, right? You're going to go back there and you're going to buy like 2x4s because that's how they basically describe the wood, or you're going to buy a 4x8 sheet of plywood. Okay, that's a dimension, right? Or if you talk about like your bedroom is maybe a 12 foot by 12 foot, room. Okay, so it's a dimension, right? And when we talk about matrices, we're talking about rows by columns. Okay, so we talk about the horizontal. Remember, please, that horizontal rows are horizontal, they go across. Okay, and columns are vertical, like the columns on a house. Okay, so we talk about rows and columns, and when we describe the matrix, we literally count up how many rows by how many columns, and we just call that the dimensions of the matrix when we describe it. Now, the elements are the individual pieces in the matrix, and we can actually call up elements or just talk about elements in a matrix by stating what row and what column they're in. Okay, and we're going to actually do that as well. All right, so, and then the last part, you've done scalar multiplication before. It's not really a big deal. It's pretty much the distributive property. Think way back. I know it's been a while. This T, that's supposed to be an R. Okay, think way back to 9th grade when you were in algebra. They had this project that they used to do that started with like a smiley face, and it was in the middle of a graph, right? And you had to make it bigger and make it smaller, and we call that dilating, right? Well, that's pretty much what scalar multiplying does to a matrix. It actually, you don't want to move. There we go. It actually dilates the entire matrix, okay? So can't get it to scroll. I don't know why it's not moving. All right. I don't know where my scroll bar is. Very sad. There we go. There it is. No, that's not what I wanted. Come on. Where did you go? That little little booger. Okay, so you are basically dilating, having technical difficulties. You are dilating the matrix, okay? You are making it either bigger or smaller, and it's multiplying every single piece inside of a matrix, okay? So those are the 4 things that we need to keep in mind. The big ones, again, right now and throughout the matrices that we're going to be dealing with are elements and dimensions. Okay, so let's actually practice some of this stuff. All right, so rows by columns. This is going to be very difficult if it will not. Wonder why it won't scroll. Very strange. Tools. No. Oh, goodness, what is wrong with this thing? Okay, I give up. I'm just going to have to figure out another way to scroll because it doesn't seem to be here. No, I can make it go back and forth. Where is my scroll bar? Very strange. Okay, so I'm going to have to figure out. No, didn't want to do that. There we go. Oh, I can scroll this way. Okay, so joy. I've actually figured out how to do it. Okay, so dimension rows by columns. So let's talk about this first matrix. Okay, so let's take a look. How many horizontal rows going across does it have? It has 2. And how many vertical, going up and down columns does it have? 1, 2, 3. So this is a 2 by 3 matrix, and that's how it's described. Okay, and I can talk about individual pieces in there based on those rows and columns. All right, what about this one? So 1, 2 rows, 2 going across, and only 1 going down, and that is possible. So that is a 2 by 1 matrix. Okay, and we're not going to worry too much about this. It's basically a general form. We'll get more into this when we start talking later about what we call the determinant. But for right now, general form of a matrix. This would basically represent row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. So it would actually describe the pieces that way as well. So don't worry too much about the general form. Don't really need it all that much. But let's talk about pulling out elements. Okay. So let's say that I have the matrix B, and, okay, 1, 7, -3, 4, 2, 9, 0, 14, 2. All right, so here's my matrix. And this is specifically a 1, 2, 3 rows by 1, 2, 3, 4 columns. Okay, so say 3 by 4 matrix. And the name of the matrix, since we've given it a letter, is matrix B. Okay, if I want to talk about a specific element in the matrix, let's say I want to talk about this. Okay, this means that I want matrix B. I want the element that is in row 1, column 2. So whatever element is in row 1, column 2 is my answer, and that is 4. Okay, so it's just a specific element, and it can represent anything. We're going to be writing matrices that represent like business stuff where they're selling things, and it talks about how many red t-shirts they sell. Okay, so it could mean anything. For right now, it's just an element in the matrix, and it's row 1, column 2, and it's 4. Now, tricky question. What if I said something like that? Okay, matrix B. And I want the number or the element that's in row 4, column 3. Well, that's a problem. There doesn't seem to be a row 4. So this actually has no answer. And it has no answer because there is no row 4. Okay, so you have to make sure that the rows and the columns actually exist when you try to answer a question like that. Okay, so that's just picking out elements and basically describing a matrix. Okay, so let's talk about adding. Now, adding and subtracting matrices is pretty easy. The only rule is that your dimensions have to match because you add it piece to piece. So like here, we would say 3 plus -3 because it's in the same spot, right? We would say 7 plus 2. And 5 plus 7 and 1 plus 4, right? So everything would be in the same spot, and we would add it piece by piece, element by element, basically. This one here, the second example, is a problem because there is nothing to add to this 4 and 9 that's on the second matrix, right? There is no column 3. So this one, literally, we would just call it as no solution, right? Because you can't add them. Okay, so this one we can add, And since our matrices are 2 by 2s, we're going to have a 2 by 2 answer, right? 2 by 2 answer. And we're just going to add them piece at a time. So let's take a look. First one, 3 and -3 is 0. 7 and 2 is 9. 5 and 7 is 12. And 1 and 4 is 5. And that's it. For adding and subtracting, it is very easy. Again, it is just element to element. So let's try a subtraction one. Make sure you've got it. Right. 7, 9, 3, 2, 6, -4. Okay, so we have a 2 by 3 and a 2 by 3, so the answer is going to be a 2 by 3. And we're just subtracting again, element to element. Okay, so 7 minus -1. So we are subtracting, so you have to make sure you're subtracting all your pieces. So 7 minus -1 is 8. Now, if you're having a hard time understanding why we got 8, then your best bet is to do what they taught you back in, middle school when you're doing your integers, is to make this addition and then change all the signs in the second problem. Okay? So then it would become 7 plus 1 and -4 plus 2, for the negative ones that are causing an issue. Okay? If subtracting is not a problem and you're catching those double negatives, then just leave it the way it is. So it's 9 minus 3. 6, 3 minus 9, -6, 2 minus 0, 6 minus 5, and -4 minus -2. Right, so it's very basic, adding and subtracting, and that's what we're going to be dealing with as far as the lesson. Now, these are just random matrices. I made them up. I just threw the numbers in there. It's not a big deal. What if the matrices were not made up, if they were actually representing something? Okay, so as an example, we can use it to represent real things. Okay, so in this case, we're going to use the matrices to represent the baseball team, what these two players have sold. Okay, so I don't want you to copy this. There's no point to it. I just want you to read it, if this thing will go away. I just want you to read it so that we can actually write the matrices together for it, okay? So we're going to write the matrices that represent these two baseball players. Okay, so they're selling t-shirts, sweatshirts, and hats. One player sold 12, 8, and 20, and another one sold 14, 2, and 12. Now, the only thing on this, as far as writing the matrix, is that we have to decide which way we want to write it, and we have to make sure we label it, okay? Because if you don't label it, then nobody knows what in the world you're talking about. So if I write this horizontally, then I'm going to say, okay, this is player 1, right? And this is his t-shirts, sweatshirts, and hats. And I'm going to label this t-shirts, sweatshirts, and hats, so that I know what it is that this matrix is talking about. Okay? And then I can do another one for player 2. And again, same order. Make sure it's labeled t-shirts, sweatshirts, and hats. Okay, t-shirts, sweatshirts, and hats. And then if I want to add to figure out what they sold together, that's going to be my total matrix. And that's going to be 26 and 10 and 32. Okay, so it's just writing a matrix to represent a real world issue. Now, we could even make these matrices bigger. We could say that they were selling gold and black t-shirts and sweatshirts and hats. And then we would have one row that would be gold and one row that would be black. And then we would have t-shirts, shirts, and hats. And it is possible to have bigger matrices. You just split up what it is you're describing and make sure you label the rows and the columns. So it's not a big deal. What I want you to work on, I don't think it's going to be the assignment that's actually on here, so give me 1 minute. Let me grab a book or a online book so I can take a look at it and figure out which problems it is, because we're going to just do add, subtract, and represent right now, and we'll talk about transformations in the next lesson. All right, let's see if I can get this to come up. Online textbook, here we go. Oh, why do I not have Wi-Fi? There we go. Okay. All right, so let's get the textbook to come open. Okay, this is going to be in section 8.3. I know that. And okay, there we go. All right, so this is going to be section 8.3. All right, so section 8.3, if you want to use the online textbook, and the page numbers are going to be 838 to 841, but don't stress, I'm not giving you 12 million pounds of homework to do. Okay, what I want you to do is numbers 2 and 4. Make sure you're paying attention to the directions. Let's see, 10, A and B, and 12, A and B. Make sure again that you're paying attention to the directions for that, otherwise it can mess you up. And then do number 61, A, B, and C. And that is the assignment for that. And have a wonderful day.